1,000 robots race across a metal grid at 4 meters per second, picking a 50-item grocery order in under 5 minutes. No human hands required. Ocado engineered this AI swarm to revolutionize grocery delivery and then licensed it to supermarkets around the world. But a catastrophic warehouse fire, a brutal patent war, and billions in uncertain investment reveal a story the technology alone does not tell. Online grocery promised explosive growth, but the numbers told a harder truth. Between 2013 and 2016, the European market more than doubled in value, reaching over 11 billion euros. Yet, as orders surged, profits lagged far behind. Analysts pointed to a stubborn cost problem. The margin on each basket was razor thin, sometimes just 1 or 2%, and last-mile delivery devoured a growing share of every sale. Industry reports describe these delivery costs as the biggest barrier to profitability, often swallowing up to half of the logistics budget. The pressure was relentless. Ocado's own financial statements showed operating margins slipping year after year, even as the company led in online sales volume. Traditional picking methods, manual carts, and pick-to-light systems could not keep up with demand or cost control. Every extra minute spent assembling an order chipped away at the bottom line. Paul Clark, Ocado's chief technology officer, described the situation bluntly. "You're fighting for every fraction of a percent." The company faced a choice: accept shrinking returns or reinvent the way groceries moved from shelf to doorstep. The only path forward was to pursue speed and efficiency at a scale no manual process could match. That commercial urgency set the stage for automation, not as an experiment, but as a necessity. The answer would have to be technical, radical, and fast enough to keep the business alive. Ocado's answer to relentless cost pressure was not just to automate its own warehouses, but to turn its technology into a product other grocers could buy. In 2016, Ocado launched the Ocado Smart Platform, OSP for short, a complete logistics and software suite designed to handle every stage of online grocery fulfillment. Instead of selling groceries alone, Ocado began licensing its system to supermarket chains worldwide, promising speed, accuracy, and lower labor costs. The OSP includes the Hive robot grid, AI scheduling software, real-time inventory tracking, and even the customer-facing website. Retailers pay an upfront fee for installation, plus ongoing license and support charges. This model lets Ocado tap into the global shift toward online shopping, earning revenue whether or not its own stores are profitable. Interest from international partners followed quickly. In 2018, Kroger signed a multi-year deal to roll out fulfillment centers powered by the OSP across the United States. Similar partnerships appeared in Japan, France, and Australia, with each new contract bringing Ocado closer to the scale needed to fund further R&D. For grocers, the appeal was clear: plug into a system that could fulfill thousands of orders per hour with the promise of sub-5-minute picking times. For Ocado, every new licensee helped spread the huge cost of developing and maintaining the Hive platform, turning a technical solution into a global business engine. Inside an Ocado fulfillment center, the core of the operation is a vast three-dimensional grid, a structure of steel rails and stacked bins that stretches across the warehouse floor and rises up to 21 levels high. This grid forms a dense, modular storage system engineered to maximize every square meter of space. On top of this lattice, thousands of autonomous robots, each about the size of a washing machine, glide on omnidirectional wheels powered by high-capacity lithium-ion batteries. Each robot is equipped with sensors and RFID readers, allowing it to identify its precise position and communicate with the central control system up to 11 times per second. When an online order arrives, the grid becomes a living network. Robots receive instructions to locate specific bins, lift them vertically from the stack, and shuttle them to dedicated pick stations positioned around the perimeter. These pick stations are fitted with robotic arms called Ocadex that can extract individual products from the bins in just over 3 seconds per item. As soon as a robot drops off a bin, it returns to the grid, ready to fetch the next container or head to a battery swap dock for a rapid recharge. The cycle repeats with hundreds of robots in constant motion, each following a carefully orchestrated route that allows the system to handle 3.5 million items per week in a single hub. The sheer density of the operation is staggering. At peak, up to 1,100 robots can operate simultaneously on a single grid, each traveling at speeds up to 4 meters per second. Every movement is synchronized to avoid collisions and minimize travel time, enabling the warehouse to fulfill a 50-item grocery order in under 5 minutes. The modular design means the grid can be expanded or reconfigured as needed, supporting everything from fresh produce to frozen goods within separate temperature zones. This hardware choreography is the physical backbone that makes such high-speed fulfillment possible, setting the stage for the sophisticated AI control logic that directs every move. At the heart of Ocado's Hive is a control system that operates more like AIR traffic control than traditional warehouse software. Each robot in the grid does not simply wander toward its goal, instead it requests a reservation for every cell it plans to cross, down to the second. The scheduler grants or denies these requests in milliseconds, weighing thousands of overlapping paths and constantly replanning as new orders arrive or unexpected obstacles appear. This reservation-based logic is what lets over 1,000 robots move in parallel, each following a precisely timed route that guarantees no two ever collide. The system's intelligence comes from a digital twin, a live virtual replica of the entire warehouse. Every robot, bin, and pick station is mirrored in software, updating in real time as the physical operation unfolds. The digital twin allows engineers to run performance simulations, stress test new algorithms, and validate that the 5-minute fulfillment claim holds even during peak demand. Telemetry from the robot streams to the scheduler more than 10 times per second, giving the AI a continuous, detailed picture of the grid's state. When a robot needs to recharge or a pod is delayed at a pick station, the scheduler instantly recalculates, rerouting traffic to avoid bottlenecks and idle time. Performance data from Ocado's flagship centers shows the power of this approach. In Erith, a typical 30 to 40 item grocery order is picked, packed, and ready for dispatch in 4 to 5 minutes, with the system handling over 220,000 orders per week. Independent benchmarks confirm that the Hive grid achieves order throughput per square meter that is 3 times higher than most automated storage systems. The combination of reservation-based navigation, real-time messaging, and digital twin validation is what enables Ocado to promise and deliver the under 5-minute grocery order, setting a new standard for speed and precision in automated fulfillment. Ocado's automation push has always carried heavy legal and financial risks. In July 2023, a patent dispute with AutoStore ended with a settlement that changed the sector's economics. Both firms gained a global cross-license for pre-2020 patents, and AutoStore agreed to pay Ocado £200 million over 2 years. The deal removed the threat of blocked Hive deployments, but future adopters now face new licensing costs and every technical step is watched closely. Patent protection remains uncertain. Any gap could invite more lawsuits or weaken Ocado's position. Financial hazards run deeper than legal battles. The 2019 Andover fire, caused by a battery charging fault, destroyed £110 million in assets. Insurance covered little, leaving a near £100 million loss and halting operations for 4 days. Upgrades followed, but the risk of sudden losses remains. For partners like Kroger, the stakes are clear. A $350 million payout in 2026 for cancelled fulfillment centers showed how fragile returns can be, even with advanced automation. Ocado's technology is no longer confined to groceries. In 2027, the company began adapting its Hive system for apparel, working with Asda to automate fashion fulfillment. Engineers fitted pick stations with soft grip end effectors designed to handle delicate fabrics and varied shapes without damage. The grid was reconfigured to store flat-packed garments and accessories, while vision-guided algorithms sorted items by size and style. early results showed a 30% boost in throughput for mixed clothing orders, with garment damage rates dropping below 0.5%. Pharmaceutical logistics brought a different challenge: strict temperature control. Ocado secured MHRA clearance for a pilot using Ember Life Sciences cold chain pods, which maintain medicines between 2 and 8 degrees Celsius. Each pod logs temperature every 30 seconds, and the AI scheduler reroutes sensitive orders through climate-controlled corridors. Over 3 months, the pilot reported 0 temperature breaches and met all regulatory standards for prescription handling. As the Hive expands, the workforce changes with it. Most pickers have been retrained as robot technicians or data analysts, but union leaders warn that not everyone can make the jump. Some technicians report higher pay and more skilled work, while others worry about job security and constant monitoring. The debate over automation's human cost is far from settled. Today, algorithms orchestrate groceries at speeds no human team can match. Yet, as automation expands into new industries, the question shifts from what is possible to what is left for people. The future of work is being written in code, line by line, bot by bot. What role will we choose?